Okay, thanks so much, Gabby. Thanks to everyone on the call. It's an honor to get to chat with you today. So I'm Brendan McEwen. I'm a managing consultant at Dunsky Energy and Climate Advisors. And I guess for the last 6 or 7 years, I've been doing work both as a consultant and previously as, for a short period of time, as a staff person at a city, developing EV-ready requirements for new construction, as well as supporting existing buildings undertake sort of comprehensive renovations to make their parking EV ready. So pleased to just provide some more information to add further color to Deborah's comments about the city's EV ready requirements, about what these requirements are, how they exist, how to comply, and some thoughts on design strategies that are going to help you maximize value in your developments. So just really quickly about Dunsky, we're consultants. We work with all different levels of government, utilities, and increasingly the private sector as well as the nonprofit sector to help advance the energy transition. So we work in buildings and industry, energy, as well as in mobility. So especially focusing on electrification of transportation. So what I'll do in the next 15 or 20 minutes or so is firstly provide a really quick review of electric vehicles and try to convince you in 2 slides that within a decade or two, the large majority of vehicles parking in new developments are going to be plug-in electric vehicles. Then I'll say a little bit about EV charging and EV-ready parking, a bit about EV energy management systems, which are an important type of technology to enable large proportions of vehicles in both residential and non-residential buildings to ultimately feature EV charging at them, and EV charging service providers that can provide EV chargers and these EV energy management systems to buildings. And then we'll cover again those new construction requirements Deborah mentioned and how to comply with those. And I'll share a little bit on design strategies to maximize value in your new construction projects. So right now, EVs are a much lower cost to operate than conventional, gasoline or diesel vehicles. They have about a third of the cost to power the vehicle and about the half of the operations and maintenance costs, but they're more expensive upfront. That's because batteries are relatively expensive. What we've been seeing, though, is that battery prices have been declining rapidly over the course of the last 30 years or so, and the projection is for ultimately that to just continue. Blips in costs due to commodity prices of things like lithium notwithstanding. So what happens is, as those battery price reductions occur, is that the cost to produce these vehicles decline. So this is an image from the International Council on Clean Transportation. It shows 3 pure battery electric vehicles here with these declining lines that show reducing first cost prices of the vehicle. So a longer range EV with 400 kilometers or 250 miles worth of range, and then also one with 200 miles, maybe 325 kilometers and 150 miles. And you can see as battery prices are declining, the cost to produce those vehicles and then presumably sell them declines, so that by the mid-2020s, they're likely to get to about parity with kind of conventional vehicles and then subsequently be even lower cost to produce. So the exact date when that happens is going to depend on different things, commodity prices and other factors, but it's definitely the trend in the not too distant future. And at that point, you're going to have vehicles that are both lower cost upfront as well as lower cost to operate. Hard to understand why people are going to want to keep purchasing internal combustion vehicles after that. But in addition to that, just kind of fundamental technology and economic story, we also have these policy drivers that Deborah mentioned. So the federal government is requiring that all new passenger vehicle sales be zero emissions, which means practically plug-in electric by 2035. So say a bit about EV charging and EV-ready parking. Broadly, there's 3 different levels of EV charging. There's a so-called level 1, that's like 120 volt, which is the same voltage as a household outlet. Some households make do with this for home charging, but it provides a relatively slow rate of charge. So 5 kilometers per hour of charge up to maybe 8 kilometers per hour of charge for your more efficient vehicles. And it can be even less at very cold times when you're going to have the heat on in the car. So although some households make do with this, it's probably not a viable sort of strategy for the mass market, nor certainly for like larger SUVs or pickups. So increasingly what people want for home charging, as well as what can make sense for workplace charging and some public charging, is level 2. So level 2 is like 208 volt or 240 volt. That's like basically a dryer plug or an oven plug type of voltage, anywhere between 12 amps and 80 amps. 40 or 50 amp circuit breakers are quite common today, although there's a range of amperages that you can have. And at that, 40 or 50 amp circuit breakers, you're probably looking at somewhere between 30 and 50 kilometers per hour for vehicles, how much range is being added for an hour worth of charging. So this is much more attractive typically for people for home charging types of applications, as well as, let's say, workplace charging and a lot of on-the-go, out and about opportunity charging. And then lastly, there's DC fast charging. This is important for sort of public applications, but it's going to be impractical and typically much too expensive for, let's say, residential or probably most workplace types of applications. Useful to have a sense of where we need charging to adopt EVs. This charging pyramid that was introduced by the U.S. Department of Energy is a useful way to visualize this. Basically, the base of the pyramid is at-home residential charging. In North America, this is where 80% of all the electrons delivered to vehicles happen, is at home. It's a very convenient way to charge your own household's personal EV. So if you've got an at-home parking space, either in a single-family home or multifamily, it really makes sense to have EV charging at that parking space. Now, maybe 15% of all the electrons right now are delivered at work, and a small but important amount in sort of public spaces, either like connecting different metro regions on a highway network or providing charging for people who don't have access to, let's say, home or workplace charging when they're out and about and on the go. But that kind of base of the pyramid, residential charging, is particularly important to enabling households to adopt an EV. It's usually pretty straightforward if you've got on-site parking to get access to at-home charging in a single-family home, even if your building wasn't future-proof to provide that. But in a multifamily building, it can be quite costly and complicated. So when you're doing approaches where you're just adding a couple of charging stations at a time, which is what has sort of predominated to date in buildings that haven't been properly future-proofed, it can be quite costly. Probably the average cost is maybe $9,000 or $10,000 per charging station. So there's real challenges to scale with that type of cost. You also have very complicated decision-making and approvals processes. So it can be quite difficult to get this approved both in condos as well as rental buildings for different reasons. And you need to be mindful when you're trying to retrofit after the fact of how much electrical capacity you have, because if you're not carefully designing EV charging systems for buildings, you can exceed the available electrical capacity in that building. So for these reasons, it really makes sense to future-proof multifamily buildings especially, but all sorts of buildings, workplaces, single-family homes too, in advance, so that we're going to be ready for the vast majority of our vehicle fleets being electric in the not too distant future. So Deborah shared a version of this graphic of the most appropriate way to future-proof those facilities. This is to make each parking space in residential parking EV ready. So you're going to have an adjacent electrical outlet that's going to have upstream electrical capacity. So you're going to have, of course, a branch panel that can feed that outlet, as well as your switchgear and feeders and the transformer for your building, all sized appropriately so that it can ultimately provide power to a vehicle via a charging station. And that EV charger or EV supply equipment, is the acronym EVSE, is installed later after the fact as households adopt EVs. So EV ready means there's that adjacent outlet to provide EV charging. As I mentioned, EV energy management systems are really important technology to enable large proportions of parking to be EV ready and then to ultimately feature EV charging in this way. So basically, EVMS, they monitor and then control EV loads. So you can see in this schematic down here, let's pretend this is a 40 amp branch circuit that's serving maybe 3 parking spaces in this case. If only one vehicle is here and parked and plugged in, it can get the full capacity of that branch circuit and charge relatively quickly. But if multiple vehicles are there and plugged in, the charging stations have some intelligence. They can communicate via a network, let's say cellular or Wi-Fi or Ethernet cable, and they can throttle their consumption up and down so that they ensure they don't exceed the capacity of the circuit and therefore risk tripping the breaker. So in many contexts, like let's say residential charging or workplace charging, having some sharing like this is perfectly reasonable. You're still going to have everyone get a sufficient quality of charge overnight or through the course of a working day, even when you're doing a relatively significant amount of load sharing in this way. So this is the basics of EV energy management systems. Worth noting that there's a number of different electrical configurations that different types of EV energy management systems can do. So that example I just showed would be an example of what we call branch circuit sharing, where you've got one branch circuit and then multiple EVC are communicating and not exceeding the capacity of that branch circuit. You can also do panel sharing, where instead of overloading branch circuits, you're overloading a panel and ensuring that that panel's capacity isn't being exceeded by that management system communicating to those different charging stations. And then for different types of buildings, this can be useful for some single family homes, also in some cases, let's say townhomes or small apartments. You would have a meter that's associated with that unit that's then feeding that unit's electricity panel. And upstream of that panel, between it and the meter, you've got your energy management system. It's monitoring the current in that feeder in real time. And whenever there's capacity, which is really the vast majority of the time, it's letting the EV charging station charge. But if you're ever getting close to the limit of that panel, it shuts off or throttles down the EV charger. So that can be useful. This kind of so-called feeder sharing or feeder monitoring type of setup is again, useful sort of technology for many single family homes, townhomes, small apartments. And for larger buildings, service monitoring is kind of more nascent. There's definitely a lot of product out there in the market that can do circuit sharing, panel sharing, or feeder sharing. There's some that can now do service monitoring, although it's again relatively newer. And what it does is monitors the service into a large building and then communicates with the charging stations so they don't exceed the capacity of a circuit. So, the takeaway from this is not to try to have everyone have a perfect understanding of all these different types of architectures, but just to understand that there are different sorts of electrical configurations and architectures that can apply to different sorts of buildings, and it's worth working with electrical consultants that can think carefully about what are the most appropriate sort of strategies for your particular development. And the advantage of this is that it's going to significantly reduce the cost to provide an EV-ready outlet in these buildings. So this is a costing study that with my previous employer, AES Engineering, we did in 2021 for Clean Air Partnership. And you can see that for this particular, I think it was a high-rise building, if you were to do things without any energy management on 40 amp circuits, you're looking at a incremental cost of about $5,500 per parking space, which is pretty expensive. But there's ways to get the cost down to maybe $1,500. I think, this was at the height of construction cost inflation. And there were things about these archetypes that made them somewhat more expensive. We definitely see certain developments that have lower costs than this. But you can get to significantly lower costs by having different sorts of configurations that are doing, in this case, branch circuit sharing, as well as some service monitoring in this last example. And worth noting that EV charging service providers are an important part of this ecosystem, especially for multifamily buildings and workplaces or other sorts of commercial properties, basically what these sorts of service providers will do is they provide charging stations to properties, and those charging stations will typically be networked and able to communicate on the energy management system that is controlling EV charging at those properties. So if your chargers are going to work, they need to be compatible with the energy management system for the building or controlling EV chargers in that part of the parkade. So it's worthwhile typically to associate a facility with one EV charger. And in addition to just like providing the charging stations and ensuring that they're going to work on the design for EV energy management, they provide other sorts of services as well. So they can do access controls to make sure that if, let's say the charger is just intended for a given resident, then not anyone can go in and charge there. They can provide billing services to reconcile electricity costs. So if the condo is paying for the utility bill, that drivers can then, via these charging service providers, provide money for the electricity that they use so that the condo is made whole. And there's a variety of other sorts of types of values. They provide dashboards and reporting, and many provide sort of customer assistance and troubleshooting and support. As we have the clean fuel standard introduced, there's also going to be opportunities to generate money through providing EV charging. So these sorts of service providers are important to do that. So those are kind of the enabling technologies and services to provide EV charging at scale in a range of different types of buildings. As Deborah mentioned, Toronto has entered the pantheon of local governments that now require EV-ready new construction. There's a couple in Ontario. I should probably update this slide. This originated in BC, and there's increasingly active development of these sorts of requirements all across the country. As Deborah noted, what you need to do to comply with the zoning bylaw is where you've got residential parking, ensure that beside each residential parking space, there's that EV-ready outlet that's going to be capable of providing level 2 charging or higher. And then 25% of the non-residential parking has to have the same. And there's these charging performance requirements that limit how much load sharing you can do on a branch circuit or branch panel. So it limits you to 4 share on 40 amp circuits. Previously, it had been 3 share, and then we did some analysis looking at what's a reasonable level given how far people tend to drive in the Greater Toronto Hamilton area and in Toronto. It's reasonable to have 4 share on 40 amp, or you could do things different ways, maybe perhaps up to 10 share on 80 amp circuits. Conversely, if you were just going to have 20 amp, each parking space would need to have a 20 amp circuit to provide that and make sure those vehicles are going to get a sufficient quality of charging experience. So to wrap up here, I'll say a little bit about strategies for residential developments that can be used to kind of maximize your value as developers. I should note, I'm not an electrical engineer. I just like hanging out with them and talking with them, and I've learned a couple of things. But certainly nothing I say is going to supplant, the value and responsibility that you're going to get from working closely with the engineering design professionals on projects. With that caveat aside, here's some thoughts. So in multifamily parking, so for instance, like an underground parkade or a surface lot, you could comply with the city's requirements by providing sort of dedicated unmanaged circuits to each parking space, but that's going to be relatively expensive. The low cost strategies that'll both be lowest costs for new construction as well as actually result in much lower power costs and utility impacts for the occupants will be predicated on using load sharing. So typically sharing across a branch circuit. That's going to, again, reduce the size of your electrical systems, reduce energy costs. It will mean that you're going to have to get EV chargers that are compatible with that system rather than just allowing households to adopt so-called dumb charging stations, unnetworked or not smart charging stations. So it makes sense to try to associate that building from the outset with a charging service provider that's going to provide good value, quality chargers at an attractive price, and other sorts of good quality of services. So shared that previously for the rationale here. Basically, you're going to look at a lot lower capital costs for those EV ready outlets. In these types of common, shared parking garages, typically what I suspect the vast majority of developments are going to do for at least the next few years is a configuration where you've got 4-share on 40 amp circuits. In other jurisdictions where this has been done, this is what I'd call bread and butter. It's very common. This is compatible with basically all of the network charging services that various charging service providers offer, and it meets Toronto's performance requirements. So this is quite sensible to do. There are certain sorts of strategies that probably aren't viable now under the electrical code, but there are active code change proposals at CSA Group to try to make them viable. That would allow, let's say, 40 amp circuits or 40 amp chargers on 80 amp circuits. So once that's enabled, there might be greater value in these sorts of configurations that would have higher amperage branch circuits sharing to larger proportions of parking spaces. So it's worth kind of monitoring that sort of space. It's not going to save huge amounts, but it is, marginal and can also provide good quality of service for the drivers. So this is something that might come down the pipe, but for the time being, I'd say that sort of 4-share on 40 amp is pretty sensible sort of configuration. Now, there may be some developments that when you do 4-share on 40 amp, you are kind of getting unlucky and it's kicking you into a larger service size, and that's causing costs for utility connection and extension fees. The electrical code notes that where you implement EV energy management systems that can monitor consumer services, you don't have to count the demand loads for the charging stations. So it is possible, although again, quite uncommon at these points, to design buildings to be able to use these sorts of service monitoring types of equipment and then negate from your load calculation those EVSE loads. This is kind of a handy thing to know back pocket, and if you're running into challenges, like discuss closely with your electrical engineering team whether this is going to be sort of a viable thing to pursue. So that's those kinds of shared parking facilities at multifamily apartments. Just also wanted to touch townhomes and single family homes where you've got on-site parking that's just an attached garage for each household that's served by the electrical panel for that household. So in those circumstances, in lots of cases, you can provide a 40 amp dedicated circuit that can support an unmanaged EV charger to that parking space, and it won't have material impacts on the service size or your panel size for the property, and it's a perfectly reasonable thing to do. There are cases where you do run into that causing electrical service upgrades, and then you need to think about what to do in those circumstances. So in some cases, that cost of the larger service might be reasonable, modest, it's something you can bear, and you just keep it simple and go with a larger service. If that would be a real challenge, then you consider in kind of the following order, I'd say. Firstly, can you provide 20 amp circuits to those parking spaces, and would then that service upgrade still be required? And then are there opportunities to use load switching or feeder monitoring and service monitoring EVMS to avoid those sorts of electrical load increases? So here's just a couple of little schematics from different equipment providers First on the right here, circuit switching, where you're load sharing between a stove and your EV charger, and that can help you reduce your electrical load calculations for your developments. That can be useful in let's say a single family home context and perhaps some townhomes. And then service and feeder monitoring. So RV has these products that monitor your feeder that's coming off of a meter bank. My understanding is that they're exploring also having something that's monitoring the service for buildings. And then, as I noted before, is monitoring these two circuits, amperage in real time, and controlling your EV charger off and on so that it's not going to exceed the capacity of those different circuits. So that can be useful for a number of different sorts of applications. Let's say townhomes or small apartments. There's other sorts of vendors, RVs based out of Quebec, and I'd say they're a market leader at this point, although there's a variety of technologies that are, introduced now in North America, and I'm sure there's others coming down the pipe. And the last thing I'll say is, again, it's important to select a quality EV charging service provider for buildings that are designed for needing networked smart charging stations. Best practice would be for developers to, on behalf of the ultimate owners, go out and seek a charging service provider that's going to work with that building and provide EV charging infrastructure for them. This reduces the likelihood of hiccups and make decisions easier for, let's say, the ultimate condo associations that are in that building. And so, it can make sense to have competitive processes or getting to know different entities in the industry. You want to think about the price of the chargers as well as ongoing fees, the quality of chargers for their installation, like, if it's outside, is it more robust? How much of a risk is vandalism, that kind of thing. Things like warranties, their market position, so how likely are they to be in business in a couple of years down the line. Certainly the use of open protocols so that it can be relatively easy for your condo association or building owner to switch charging service providers or to switch hardware. These are all important considerations when you're selecting a charging service provider. So thanks so much. I hope that's useful context, and looking forward to answering any questions to the best of my ability.
Thanks, Brendan. Thank you so much. That's a lot of information. I get that. That's a lot of information thrown at people all at once. So if you have any questions, you could just either raise your hand, you could just put them in the chat, or you could unmute. But there is a question from Rob that I wanted to kind of raise. And I just wanted to, Rob, if you can give a little bit of insight in terms of whether your question was answered. But he was looking for the ratio of transformers that need to be installed in an EV ready building versus a non-EV ready building. And I'm not sure if it can be answered in that sense. It will depend on how many parking spots are in existence and the energy sharing that is taking place on that one. But Rob, if you wanted to kind of ask any kind of clarifying questions on that you were seeking some information on, if Brendan wasn't able to answer it.
Yeah, I couldn't say this is the specific ratio.
Yeah.
Without, knowing a bit about the building.
The design of the electrical kind of, yeah.
Yeah. I mean, it'll be less, I guess. It's going to require less power when you're designing for load management.
Mm-hmm. Okay. Rob, did you have any follow-up questions you wanted to ask on that?
No, thank you. I'll look through some of the stuff Brendan gave. Thanks, Brendan.
Okay,
Sure thing.
Thank you.